Okay, we're going to start our next chapter now, and I broke this one up into 4 small videos, so your videos will be shorter this time. So our first one's about forces. So you probably know just the basic definition of a force. So the force is going to be a push or a pull, and that force is going to be acting on an object. So there's a good chance that 2 forces can be acting on an object at any given time. So some examples of forces would be lifting something, dragging something, floating globe. Sometimes your forces are balanced. So if 2 equal forces are applied to an object in opposite directions, but the object does not move, or that object is moving at a constant speed, that is called a balanced force. Another way to say that is that object is at equilibrium. The other option is there's unbalanced forces. So if there's 2 unequal forces that are applied to the same object and they're in opposite directions, the object does move. This is called unbalanced forces. And so in the example of tug of war there, someone's going to be winning. So unbalanced forces. So if the forces acting on the object are not balanced, then here's some options that could happen. So something could speed up, something could slow down, something could change direction, or it could change the shape. Here's some force diagrams, and we're going to practice this in class. So you have an object, and a lot of times that object's going to be represented by a box. Okay, so you don't have to actually draw the actual object, but you could just draw. And so here we have a box, and it says the block has 2 opposing forces being applied to it. 7 newtons to the right and 4 newtons to the left. And newton is the unit for force. And so they're unbalanced forces. They're not the same amount. So in order to calculate the resultant force, in other words, in order to calculate how much force you have left after they cancel each other out, you're going to subtract. So 7 minus 4 is 3. And then they're going to go to the direction of the bigger one. So 7 is bigger than 4, so your answer is 3 newtons to the right. Is that easy enough? Okay, here's a problem for you in same kind of format, but just in a word problem. A man of mass of 75 kilograms has a weight of 750 newtons. This 750 newtons will act downward on the table. So we have a force downward of 750 newtons. The table will exert a 750 newton force upwards on the man. The forces are balanced. What would happen if the upward force were less than 750 newtons? Well, think about this. So if this force going up is not as strong as the force going down, then the table would break. Okay?